Pentane was an oxygen? Okay, yeah, that's a hydrocarbon. Okay, when you have that PENT, that means 5, that's on the front of your formula. A and E means it's all single bonds between carbons. That's a hydrocarbon. That's the naming system we have for hydrocarbons. So it's a hydrocarbon and oxygen, and anytime you react those, your products are always going to be, at least in this class, carbon dioxide and water.
We just write carbon dioxide
Hmm?
We just write carbon dioxide
That would be the answer to the question he asked. Okay, Katie?
I have never seen what products to do expect those things to react in our reactions.
Well, that's what we just did. That's what we were saying a while ago. On water and a chemical salt. Exactly right. So, looking at this equation up here, what's our chemical salt? Huh? Calcium phosphate is our chemical salt. Okay? Well, there are a couple of ways to define that. Any ionic compound other than oxides are usually going to be a chemical salt. Okay? So that's not an oxide. It has oxygen in it, but it's not an oxide. An oxide means you've got just an oxygen anion. Okay? When we get to the acid-base chapter, we'll refine that definition a little bit, so that a salt is any product other than water of an Arrhenius acid-base reaction. Okay? So by that definition, this is a salt because it's a product of an Arrhenius acid-base reaction. Okay? But for right now, any ionic compound other than an oxide we'll consider a salt. Yes?
Maybe number 11, it's like a compound.
Sure.
Okay. In water in aqueous environment, NaCl plus F2 to like give the reaction.
Okay, so we want to know what's going to happen if we have an aqueous environment, and we're using Na, F2. Oh, I'm sorry, F2 is by itself?
Yes, sir, NaCl.
Okay, F2 is by itself, and you got NaCl. Okay? And this is in water. All right? Okay. While a small amount of fluorine will dissolve in water, that's usually considered a gas. Okay? We said the other day, and I don't know if I did in this class or some other class, but hydrogen is considered a gas, even though a small amount will dissolve in water. Oxygen is a gas. Nitrogen is a gas. Fluorine, and that's F2. Chlorine is a gas. Okay? So elemental hydrogen, oxygen, nitrogen, fluorine, and chlorine are all gases. Okay? So you would identify this as having a physical state of a gas. Okay? If I put NaCl in an aqueous environment, question is, does it dissolve or does it remain a solid? Ionic compounds, if they're not dissolved and you don't heat them up really, really hot, they're going to be a solid. Okay? They just are. All right? So you're going to use the solubility rules to figure out whether NaCl will dissolve or not.
Nitrate is soluble.
Nitrate.
Is it on
What?
Wait, what?
Sodium chloride. Is it going to dissolve or not?
Oh, okay, I'm sorry. I thought you said something.
Did I say the wrong thing?
No, I was
Everybody should be looking at their solubility rules and practicing. Trying to figure this out. Okay? Carolyn says it's soluble. Does anybody disagree? All right. There's two ways to look at this. Sodium is in the first column of the periodic table, and that makes it a group 1 salt. Metal, non-metal is ionic. That makes it a salt, right? Unless it's an oxide. That's what you said, right? So it's a group 1 salt. So it's aqueous because it's a group 1 salt. And that's what it says up here. They're soluble. This is what it can do in the solubility rules. Soluble means that's what it can do. You have to decide if it will do that. And in water, soluble things are going to be aqueous. That's what you have to decide. Okay? Now, it also turns out that chlorides are soluble. And there's no exception for sodium. If chlorides are bonded with silver, lead, or mercury 1, it would be an exception, but that sodium obviously is not those things. So this is going to be aqueous. Okay? We need to know if there's a driving force. Now, in our previous question up here, determining if there's a driving force was all about figuring out what the products were going to do. If you form a liquid, if you form water, if you form a solid, or if you form a gas, that's a driving force for a double replacement reaction. For single replacement reactions, determining if there's a driving force is all about the reactants. Okay? So how do you figure out if you're going to have a single replacement reaction that will happen? Activity series. So something in this formula here, this is the element that's by itself. Okay, it's bonded to itself, but that's still by itself. Okay? And here's a compound, and you want to find something in this compound that is like this element that's by itself. So one in this compound is like this fluorine, the chlorine. They are both halogens. Okay? Back when we were in the second unit in here, we were identifying regions of the periodic table. And we found that the name of this column right here was the halogens. So fluorine is like chlorine because they're both halogens. Okay? So now we've got to go back to our activity series and figure out if fluorine will replace chlorine. So look at your activity series and figure out if fluorine will replace chlorine. Okay? Mackenzie says yes. Who disagrees with her?
Does that mean it's like underneath it?
No, this is just a different activity series. Halogen activity series. Okay? So fluorine is higher than chlorine. So fluorine, the element, should displace the chlorine ion. Okay? This works the same way as this activity series of metals over here. If one's higher than the other, it's going to displace it. Okay? So fluorine will be able to displace that chlorine and kick the chlorine out, basically. So we're going to move over here and we're going to put the sodium with the fluorine. And we're going to write chlorine by itself because it got kicked out. Okay? Now we need to figure out, we don't have to worry about physical states necessarily because we already figured out there's a driving force. We do have to figure out physical states, but not for the driving force. So we said chlorine by itself is going to have what form? Chlorine that's by itself is going to have what form? It's going to be a gas. Can you tell me something else about it? It's going to be two of them. It's Cl2. In fact, you don't have to look there. It's right here. It says Cl2 there. When it's by itself, it's Cl2. When it's an ion, it's not. Okay? Necessarily, anyway. All right? So I need to find out how to balance a combination of sodium and fluorine. What kind of compound is this? Huh? It's an ionic compound. Okay? So we're going to look for charges and figure out how to balance them. I need to know what charge exists on both those ions. 1 plus and 1 negative. So sodium is a 1 plus, fluorine is a 1 negative. How many of each of those do I need to get the whole thing to equal 0? 1 and 1. Does anybody need me to do the math? Okay. So that's balance. We didn't know what physical state to assign for that. Where do we look for that? Solubility rules, right up here above the activity series. Okay. There's fluorides. That's what we're talking about, a fluoride. Okay. All fluorides except group 2. That's group 1. It's not group 2. All fluorides except group 2. Lead 2, not lead. Iron 3, not iron 3. So this must be soluble, and if there's water around, it will be aqueous. Okay? Now we're ready to balance the equation. Got everything else set up. We're ready to balance the equation. Yep.
How would you choose if it's a liquid? Like, how would you...
Well, the only liquids that we've dealt with in here is water.
So we don't really have to label any liquids?
Well, you should know that mercury by itself is a liquid. You know, I mean, I think everybody kind of knows that, right? But I don't think we've really talked about anything else being a liquid in here. Okay, so I would have to tell you about just about everything else at this point. Okay, can you balance the equation? This is a single replacement reaction. We have a single replacement or single displacement. Okay, so the classification of this reaction is single displacement. So balance the equation, and while we're here, we go ahead and write net and complete and net ionic equations for it. What? This is single replacement or single displacement. So please write a balanced equation, and then write a complete ionic equation, and write a net ionic equation.